Hello everyone, this is Kunal Mehta from Make Me Scientific, and in this video we are going to discuss about the physical quantities and measurements, chapter number 2, grade 8 ICSE physics. So what am I going to do is I'll cover all the topics in short, precise and to the point. So first of all, in this chapter there are three terms which are very important: mass, volume and density. So what do you mean by mass? Mass is the amount of matter for the quantity of matter in an object. Volume is the amount of space that is occupied by an object. Density is represented by a symbol rho, and density is mass per unit volume. So the formula for the density is mass upon volume. So if I take this as unit volume in physics means 1 meter cube or 1 centimeter cube, something like that. So that means the density itself will become mass divided by unit volume, that means 1, and anything divided by 1 is the same number. So density itself becomes equal to the mass. So density is equal to the mass of the body per unit volume. Okay, and it measures that how much tightly the objects or the molecules or the atoms are inside the object. Now let's discuss about mass. The mass is the amount of matter in an object. It is of course a fundamental property. It does not change with the location. However, weight changes with the location. So this adjacent figure, you are able to see a beam balance. A beam balance has two pans, right? It has two pans, and suppose if you want to measure the mass of the clock, then the clock has to be put in one pan, and the equivalent specific masses are to be kept in the another pan. And when the total mass on one pan becomes equal to the mass of the clock itself will be equal to the total mass which is lying in the other pan. Okay, and a smaller version of the beam balance that is mostly used by goldsmith, nowadays outdated, are the physical balances. So physical balances are something which are very, very small, and they are kept in a box so that the air and the wind, they do not hinder our very tiny and delicate masses measurement. The SI unit of the mass is kg, and the CGS unit is gram. So 1 kg is equal to 1000 gram or 10 to the power 3 grams. Please remember. Volume is the amount of space that is occupied by an object, right? And the SI unit of the volume is meter cube, and the CGS unit is centimeter cube, right? And the other units of the volume are liters. And you need to remember that 1 meter cube, centimeter cube, as well as liters are the other units. 1 meter cube is equal to 1000 liters. Please remember in this whole chapter. One more thing, 1 centimeter cube is also equal to 1 ml. This is what also you need to remember. Okay. Now, if you want to convert 1 meter cube into centimeter cube, 1 meter cube can be written as 1 meter into 1 meter into 1 meter, right? And 1 meter is equal to 100 centimeter. Again, this is equal to 100 centimeter. Again, that is equal to 100 centimeter. So that means we have 1 and then 6 zeros, centimeter cube, or this can be written as 10 raised to 6 centimeter cube. So meter cube into centimeter cube can be converted in this way. Now, for solids, we have fixed shapes, right? And fixed shapes, so we have cube, we have, this is a cube, and in cube, the length, the breadth, and the height are the same. And the height of the cube is also A. So the volume of the cube is written as A cube, whereas this shape is cuboid. In cuboid, the length, breadth, and height are different. So the volume of the cuboid is given by L into W into H, or you can also use the symbol B for the breadth. Okay, this is a sphere, and the volume of the sphere is given by 4 by 3 pi r cube, where r is the radius of the sphere. This is a cone, and the height of the cone, that means from the vertex till the bottom, is the height of the cone, that is h, and 1 by 3 pi r square h, where r is the radius of the circular base of the cone. The lower part, this is the base, and the radius of that base is r, so that needs to be substituted here. This shape is cylinder. The volume of the cylinder is given by pi r square h, where r is the radius of the top part or the bottom part circular section. Right? And height is h. So this is h, which is mentioned over here also. So volume of the cylinder is given by pi r square h. So these formulas, couple of formulas you need to remember. All right, we come to a very important part of the chapter, that is density. So whatever we had talked till now was just the basics. So that is something which you should remember. Now density is mass per unit volume. It is represented by rho. So m by v. So SI unit is kg per meter cube, or CGS unit instead of mass, we can write down the unit as grams, and over here centimeter cube. So 1 gram per centimeter cube is 1000 kg per meter cube. Now, how can we prove this? See, we start with 1 kg per meter cube. This can be written as 1 kg upon 1 meter cube. So 1 kg is equal to 1000 grams. Now, 1 meter cube, just now we proved that it is equal to 10 raised to 6 centimeter cube, right? You can refer to the previous slides. Now, what happens is this equals to 10 raised to 3 upon 10 raised to 6 gram per centimeter cube, which is equal to, this 6 goes up, so it is 10 raised to minus 3 grams per centimeter cube. So we started with 1 kg per meter cube, that is equal to 10 raised to 3, so that is 1 upon 10 raised to 3, or 1 upon 1000 grams per centimeter cube. This 1000 goes on the other side, so 1 into 1000 is 1000, so 1000 kg per meter cube, that is equal to 1 gram per centimeter cube. This is how we can convert it. All right, if you look at a solid or a gas or a liquid, then inside the solids, we can very well see that the atoms are very, very closely packed. So you can see that in solids, all atoms, they are very closely packed. The intermolecular spaces are very small. So that means the mass in a given volume, if you consider this as a cube, in a given volume, the mass is large because there are more number of particles. Here in liquids, you can see that there are fewer number of particles. The interatomic spacing is comparatively larger than that of the solid. So here the mass will be quite less compared to that of the solids, right? It will be slightly less compared to that of the solids. And in gas, the interatomic spacing is so high that there are very small number of particles inside that particular given volume, which makes the mass in a given volume to be very small. So provided all three boxes are of same volume, you can very well see that the volume is same, the mass is largest in solids. So that means the density, which is equal to mass upon volume, for a given volume, the mass is found very highest in solids. So density of solids is higher than that of the liquids and higher than that of the gases. This is a general overview, guys. We are not supposed to, say that it is true for all solids, liquid, gases. For example, wood floats on the water. So the density of wood is less than that of the water, correct? And on the other hand, the density of mercury is 13.6 gram per centimeter cube, which is very high compared to that of the iron, which is 7.8 gram per centimeter cube. So few densities that I would ask all students to remember is 1 gram per centimeter cube. This is the density of water. Density of mercury, that is hydrogen, that is 13.6 gram per centimeter cube. And this is mercury. Then we have density of iron, that is 7.8 grams per centimeter cube. So this is iron. Now, if you want to convert this into, say, SI unit, this is 1000 kg per meter cube. Multiply this number by 1000, 13600 kg per meter cube. Again, multiply this number by 1000, 7800 kg per meter cube in SI units, right? Now, see, from density, what can we conclude? If the density of the material is high, that substance will sink in that liquid whose density is low. So, for example, if I say that this is a solid whose density is, say, 7.8 gram per centimeter cube, which is iron. and this is water. So the density of water is 1 gram per centimeter cube. So if you immerse this solid inside the liquid, what happens is this solid is going to sink. So if the density of solid is greater than the density of liquid, the object or the solid sinks in the liquid. And conversely, if the density of the solid is less than that of the solid is going to float on the surface, right? So these are some things that we can understand from the density. On the other hand, if the density of the material is high, we can also say that the atoms are very near, it's densely packed, something of that sort. Moving ahead, if you want to measure the volume of what? Solid, liquid, and gases, we will talk later. Right? So if you want to measure the density the volume of the solids or liquids, you require few of these apparatuses. So measuring cylinder is the one, then beaker, measuring cans, pycnometer or relative density bottle or specific gravity bottle, Eureka cans, and the measuring jars. Out of these, the measuring cylinder part, the pycnometer part, and the Eureka can are very important for our syllabus. Okay, so this is a measuring cylinder, right? And measuring cylinders have graduations on its body. Graduation means the marking. So for example, if I look at this and if I look at this number, this is 190, sorry, this is 190 and the other number, this is 190 and this is 210. So that means there is a gap of 20. And by the way, it is ml, so it is 210 ml, 190 ml. So the gap is 20 ml. And in that gap, you have 10 divisions. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 divisions corresponds to 20 ml. So 1 division corresponds to 2 ml. This is the least count of, this is known as least count of this measuring cylinder. All right. So the minimum amount that can be measured with the help of this measuring cylinder is 2 ml. Here this directly starts with 30 ml. So if I make 0, then I will have 2 ml, then 4, 6, 8, 10, like that. I will have to reach till 30 ml. So the minimum amount of water that can be filled inside the measuring cylinder is 2 ml. And that is the least count of the measuring cylinder. You can, of course, change the graduations and change the the least count of this measuring cylinder. Now, this can be made up of glass or this can be made up of plastic. This is made up of borosilicate glass, right? So this can be used to measure the volume of the irregular solids. How come? So for example, this is your measuring cylinder, which already consists of, say, 70 ml of water. So the water is already filled till here, 70 ml. Now, suppose there is a small stone and the thread here. I want to measure the volume of this irregular shaped stone. So I'm going to lower this stone such that the stone is completely immersed inside. Due to this, some amount of water will rise up. And the amount of water that rises up is said to be displaced water. And suppose the water rises till 90 ml. Earlier it was 70 ml. So the change in volume, if I call this as V final and this as V initial, then the volume of the stone is equal to V2 minus V1, that is V final minus V initial, that is 20 ml. Larger the stone, more the water it is going to displace. So the final volume will be comparatively larger. So this is how we can measure the volume of the irregular solids. Now, simply if you have some liquid and if you want to measure the volume, simply fill it inside. Suppose if you fill the water till here, then the volume of the water itself is equal to the volume of the container, and you are filling the container till 110. So the answer is 110 ml. That is how you can also measure the volume of the liquids. Now, let's solve a numerical. This numerical says that there is a pebble and this pebble has, say for example, the mass 33 grams. Pebble means a small stone, you can consider something like that, right? And then there was water already inside till 60 ml, right? Now, the moment you put the stone inside, the water level rises and becomes 74 ml. So I should say final volume 74 ml and initial volume is 60 ml. So the volume of the stone itself or the pebble is equal to the volume difference in the volume 14 ml, which is equal to 14 centimeter cube because 1 ml is 1 centimeter cube. So from here we can find the density of the pebble or the stone, mass of the stone upon volume of the stone, that is equal to 33 grams divided by 14 centimeter cube. This is divided by 14 centimeter cube and the answer would be somewhere around 2.35 gram per centimeter cube. If I'm being asked to write this answer in SI unit, I will multiply this number by 1000. So 2350 kg per meter cube is the answer to the problem. Now let's look at some of the errors that we can make while taking the observations of the volume in the measuring cylinders, right? So the first thing is, suppose the level of liquid is still here, right? Till this red dotted line, then this is position number 1, position number 2, position number 3 of the eye. So the eye has to be exactly in alignment or in the line of the liquid which is filled till here. So if the liquid is filled till red line, your eye should be in the level of the liquid. If you look from a certain higher or certain lower positions, you will get a false reading, and due to the inappropriate position of the eye, we can get a parallax error. Parallax error are those errors which are found in meniscuses. Meniscuses I will discuss shortly, and that is due to the inappropriate position of the eye. So your eye should be in the level of the liquids, right? Now, suppose if we talk about the water. So this is water in a glass test tube or the glass measuring cylinder. So these are two water molecules. Now these water molecules, they attract each other with a force of cohesion. So the force of cohesion is something which is the force between two similar particles. And now here I will show it by different color. So this is a glass molecule which is shown by green color. I hope you can see this. If it is not visible, I'll make it black. This is a glass molecule, right? And then we have the adjacent water molecule, which is over here. So the force between two different kind of molecules or atoms is known as force of adhesion. Now, in case of water in a glass, the adhesive force is greater than cohesive force. So when the water goes down, some water sticks to the glass because water loves glass more than the water loves water, right? This is experimentally proved. We don't have to do anything with that. And due to which you get this shape. This curved structure that you get is known as meniscus, and this meniscus is known as concave meniscus in case of water, right? Now, when you fill it with mercury, when the glass test tube is filled with mercury, then these are two mercury molecules. They have cohesive force between them. I would write Fc. This is Fc. And over here, suppose you have a glass and you have another molecule of mercury. This is mercury molecule. This is glass molecule. The attraction between them is adhesive force. Here in this case, it is found that cohesive force is more than the adhesive force. And this shape that you get, the upward shape that you get, is the meniscus, which is known as convex meniscus. Now, the problem lies when these kind of meniscuses are there, how do we take the reading? So this slide explains very well. So this is a concave meniscus in case of the water. So there is water which is filled in the test tube or the measuring cylinder. Now you have to see the lowermost part of the meniscus. So you can see that this line corresponds to the lowermost part. I will use different color. This line, the yellow color line, is the lowest part of the meniscus, right? And that has to be taken in the consideration. So 200 ml is the correct answer. So the liquid which is filled inside this test tube or beaker or anything made up of glass having graduations has a volume 200 ml. We are not supposed to look at the top surface, not this one. We are supposed to look at the bottom part of the meniscus or the top part of the meniscus. So in this case, you can very well see that we have mercury, which is forming the convex meniscus, right? Sorry. Mercury, which is forming the convex meniscus. Here, the topmost part of the meniscus is to be considered. So whatever is the reading here, suppose the reading over here is 100 ml and reading over here is 90 ml. So that is a very large difference. It cannot happen. Just for an example, then your correct answer is 100 ml and not the 90 ml. Now, these are the beakers which have graduations, and all the beakers, they have a proper graduations. This can also be used to measure the volume of the liquids or the volume of the solids as well. In case of solids, suppose you fill the water till 300 ml. Till here we have water. Then you immerse the irregular solid like stone and the water level goes up. So the water level displaced is by 100 ml. So 100 ml is the volume of the stone. These are measuring jars. Same thing, instead of the glass, they are made up of plastic and they have graduations. These are the measuring cans, which are mostly found at petrol pump, right? So they are also used to measure the volume. Now, let's understand how to measure the volume of the liquids and how to use that calculation to find the density of the liquids. So suppose we have a picnometer bottle. So picnometer bottles are very, very small. I will shortly show you how small they are. And they have a stopper on it. So this is a stopper. So what happens is you open the stopper, fill it completely with the liquid, and then insert the stopper inside it. So the extra liquid will overflow out. That is what you will see shortly. And then the amount of liquid inside will be 25 centimeter cube. We will measure the mass, let me call the mass as M1 of the empty picnometer bottle. And that I'm going to use the weighing machine. So this is a weighing machine and the mass of the empty picnometer bottle is M1. Now you are supposed to completely fill this with liquid. Suppose till here, the liquid is filled. Let me use another color. The liquid is filled completely. Then you insert the stopper into it. And then the new mass is M2. And of course, M2 will be larger than M1 because compared to empty picnometer bottle or the specific gravity bottle or relative density bottle, you have liquid inside it, right? So first thing, mass of empty bottle is M1 grams. Mass of empty bottle plus liquid is m2 grams. The mass of only liquid will be m2 minus m1 grams, right? If you take a difference, you will get the mass of the only liquid. Now, the volume of the liquid is the volume of the picnometer bottle, which is 25 centimeter cube or 25 ml. So we know the volume as well. So the density of liquids is equal to mass of the liquids, that is m2 minus m1, divided by the volume of the picnometer bottle or the volume of the liquids. We use the picnometer bottle for the measurement of density only for liquids, not for solids. So I'm hereby completing part 1 of the video. In part 2 of the video, we will summarize what we have learned, and we will also extend our understanding to the measurement of densities of solids and relative density.